Black holes are among the most fascinating and mysterious objects in the universe. They captivate our imagination and challenge our understanding of the cosmos. These enigmatic entities have been the subject of countless studies and theories, each trying to unravel their secrets. Imagine a place where gravity is so strong that nothing, not even light, can escape. That's a black hole. This immense gravitational pull is due to the black hole's incredibly dense core known as the singularity, where all its mass is concentrated. These cosmic entities are regions of space-time where matter has been squeezed into an incredibly small space. The result is a gravitational field so powerful that it warps the very fabric of space-time around it. This warping effect is what causes the dramatic bending of light and the strange, almost surreal visual distortions we associate with black holes. Black holes are often depicted in science fiction as cosmic vacuum cleaners, sucking up everything in their path. However, this portrayal is a bit of an exaggeration. While black holes do have the ability to pull in nearby matter, they don't actively seek out objects to consume. While their gravity is indeed immense, they don't roam the universe gobbling up stars and planets. Instead, they remain relatively stationary, only affecting objects that come too close to their event horizon, the boundary beyond which nothing can escape. In reality, black holes behave much like any other massive object in space. They exert gravitational forces on their surroundings, influencing the orbits of nearby stars and planets. This gravitational influence can be observed in the way stars move around the center of our galaxy, hinting at the presence of a supermassive black hole. If our sun were to suddenly become a black hole, don't worry, it won't. Earth wouldn't be sucked in. The mass of the sun would remain the same, and so would its gravitational pull. The only difference would be that the sun's light and heat would be gone, plunging our solar system into darkness. Instead, our planet would continue to orbit the black hole just as it orbits the sun now. The gravitational relationship would remain unchanged, and life on Earth would continue its cosmic dance, albeit in a much colder and darker environment. This thought experiment helps us understand that black holes, while powerful, are not the universe's ultimate destroyers, but rather, they are fascinating objects that continue to intrigue and inspire us. How do these cosmic behemoths form? Most black holes are born from the death throes of massive stars, stars much larger than our sun. When these stellar giants exhaust their nuclear fuel, they can no longer support themselves against their own gravity. The star's core collapses in on itself, compressing matter into an incredibly dense point called a singularity. This collapse triggers a supernova, a spectacular explosion that can outshine an entire galaxy. If the core's mass is large enough, the gravitational collapse continues unabated, forming a black hole. The boundary beyond which nothing can return is called the event horizon. Gravity is the force that governs the motion of planets, stars, and galaxies. It's the same force that keeps you firmly planted on Earth. The strength of gravity depends on two things: mass and distance. The more massive an object, the stronger its gravitational pull. The closer you are to an object, the stronger its gravitational influence on you. Black holes have an immense amount of mass concentrated into an incredibly small space. This means their gravity is incredibly strong, especially at the event horizon. Let's imagine the impossible for a moment. Picture the vastness of space, the twinkling stars, and the serene beauty of the cosmos. Now let's introduce a twist to this tranquil scene. What if our sun, the very heart of our solar system, suddenly transformed into a black hole? This might sound like a scene straight out of a science fiction movie, but let's delve deeper into this hypothetical scenario. While the sun is massive, it's not nearly massive enough to become a black hole under normal circumstances. Typically, only stars with masses several times greater than our sun can end their lives as black holes. But for the sake of our thought experiment, let's pretend it could. Imagine the sun undergoing a dramatic transformation, collapsing in on itself and becoming a black hole. If the sun were to become a black hole, its gravity would remain the same. This might seem counterintuitive, but the gravitational pull at the distance of Earth's orbit would be unchanged. This is because the black hole would have the same mass as the sun. The mass of the sun doesn't change, it's just compressed into an incredibly small space. The difference is that all of that mass would be concentrated into a much smaller space. Instead of the sun's vast glowing surface, we'd have a tiny dense point. Instead of a giant ball of hot gas, we'd have an incredibly dense point of darkness. This black hole would be so dense that not even light could escape its gravitational pull, rendering it invisible against the backdrop of space. The Earth and other planets would continue to orbit this black hole just as they did the Sun, as long as they remained outside the event horizon, the point beyond which nothing can return. The event horizon is the boundary around a black hole beyond which nothing, not even light, can escape. It marks the point of no return. Our solar system would look drastically different with a black hole at its center. The familiar warmth and light of the sun would be replaced by an eerie darkness. This thought experiment helps us appreciate the delicate balance of forces that govern our universe and the unique role our sun plays in sustaining life on Earth. So, while the sun transforming into a black hole is purely hypothetical, it serves as a fascinating reminder of the wonders and mysteries of the cosmos. Section 5. Earth in Peril. Navigating a sunless solar system. Without the sun's light and heat, Earth would become a very different place. Temperatures would plummet, plunging the planet into a perpetual deep freeze. Plants would no longer be able to photosynthesize, and life as we know it would cease to exist. But even though our planet would be plunged into darkness, our orbit wouldn't change. Remember, the black hole would have the same mass as the sun. Earth would continue to orbit the black hole just as it orbits the sun now, but without the benefit of sunlight. Section 6. The fate of our planetary neighbors. The rest of the solar system would also experience dramatic changes. The outer planets, now far removed from any source of heat and light, would become even more frigid and inhospitable. Comets, once warmed by the sun's rays, would remain frozen solid, their tails no longer blazing across the night sky. The solar system, once a vibrant and dynamic place, would become a cold and desolate realm. However, the planets would remain in their orbits. The gravitational pull of the black hole would be the same as the sun's, so the planets' paths wouldn't be affected. Section 7. A glimmer of hope in the darkness. While the scenario of the sun becoming a black hole is terrifying, it's important to remember that it's also incredibly unlikely. The sun simply isn't massive enough to undergo such a fate. Black holes form from the collapse of stars far more massive than our own. Our sun is destined for a different, though no less spectacular end. In about 5 billion years, the sun will exhaust its nuclear fuel and begin to swell, becoming a red giant star. Its outer layers will engulf the inner planets, including Earth. Section 8. Black holes not your everyday cosmic threat. While black holes are fascinating objects, they're not the cosmic monsters they're often portrayed to be. They follow the same laws of physics as everything else in the universe. Their gravity is strong, but it's not infinite. You have to get very close to a black hole to experience its extreme effects. The event horizon marks the point of no return. But beyond that boundary, a black hole's gravity behaves much like the gravity of any other massive object. Section 9. The Sun's Fate. A journey to white dwarf stardom. After its red giant phase, the sun will eventually shed its outer layers, leaving behind a small, dense core called a white dwarf. This stellar remnant will slowly cool over billions of years. White dwarfs are incredibly dense objects, but they're not black holes. They're the final stage of evolution for stars like our sun. The sun's transformation into a white dwarf will mark the end of our solar system as we know it, but it won't be a sudden catastrophic event like a black hole formation. Section 10. Our place in the cosmic timeline. The vastness of the universe and the timescales involved in stellar evolution can be difficult to grasp. Our sun is about halfway through its lifespan, and it will be billions of years before it reaches the end of its life cycle. In the grand scheme of things, humanity is a relatively new arrival on the cosmic scene. We've only just begun to explore the wonders of the universe and unravel its mysteries. As we continue to study the cosmos, we gain a deeper appreciation for the beauty and complexity of the natural world. Section 11. Embracing the wonders of the universe. The night sky has always been a source of fascination and inspiration for humanity. From ancient civilizations to modern-day astronomers, the stars have guided us, inspired myths, and sparked scientific inquiry. The study of black holes and other celestial objects reminds us of the vastness and wonder of the universe. These enigmatic phenomena challenge our understanding of physics and push the boundaries of what we know about space and time. While the thought of the sun becoming a black hole is a sobering one, it's important to remember that it's a highly unlikely scenario. Our Sun is a relatively small star and will end its life as a white dwarf, not a black hole. This knowledge allows us to appreciate the life cycle of stars and the delicate balance of forces that govern the cosmos. Instead of fearing the unknown, we should embrace the opportunity to learn more about the cosmos. Planetariums, observatories, and educational programs offer us the chance to explore the universe in ways that were once unimaginable. By engaging with these resources, we can deepen our understanding and fuel our curiosity. By studying the universe and its many mysteries, we gain a greater understanding of our place in the grand scheme of things. Each discovery, whether it's a new exoplanet or a distant galaxy, adds a piece to the puzzle of our existence. It reminds us that we are part of something much larger than ourselves. The universe is full of wonder and awe, and it's up to us to explore and appreciate its many marvels. From the smallest particles to the largest galaxies, every aspect of the cosmos holds secrets waiting to be uncovered. As we continue to push the boundaries of our knowledge, we not only learn more about the universe but also about ourselves and our place within it.